Hi everybody, we are on page 5 for a brand new topic in the coordinate geometry packet. So go to page 5, and today is Wednesday, March 17th. It is St. Patrick's Day, and I accidentally used green. I promise you I did not do that on purpose, which makes it even cooler. So happy St. Patrick's Day, page 5. And let's figure out what this even means. Partitioning a directed line segment. What does that mean? If you had a line segment, which means it ends at both ends, and you wanted to partition that, partitioning really just means breaking things into pieces. A partition in an office is like a piece of a wall that divides it into different spaces. So a partition of a line segment is just some division. If I had to take this point, I could partition it here, I could partition it here, anywhere along this line, and you could make a ratio. Like if this would be like a midpoint. It would divide it into a 1-to-1 ratio because the left is the same as the right. However, if I put it here, I might say that that is, let's see, if it was broken up into fourths, and I put the point here, that might look like a 1-to-3 ratio because there's one section here and 3 equal sections on that side, so 1-to-3. Okay, and that can be moved all over the place. So I could move it way down here, and let's just say it was broken up into, let's do 1, 2, 3, 4, 5, 6, 7, 8 sections. There are 1, 2, 3, 4, 5, 6, 7 on the left and 1 on the right, so this would be broken up into a 7-to-1 ratio if the point was here. But we're going to move that all over the place. So let's take a look at these steps here, 1 through 7. It looks like a lot of steps, but you're going to be surprised at how fast those go once we get sort of fluent with this after 1 or 2 examples. It won't seem like 7 steps at all. So if we look at example 1, it says the endpoints of AB are 0, 0, and 8, 8. This particular problem doesn't have an XY axis on the graph paper yet. So I'm going to show you how to do it with graph paper. You'll always have that available to you. There's another way to do it, which I'll show you. But we have 0, 0, and 8, 8. There we go. 0, 0, and 8, 8. And we're looking for, we'll connect that to make a segment out of it. And we're looking for the point that divides or partitions that segment into a 1-to-3 ratio. Alright, so let's look at the steps. Plot both points and connect. Done. Create a right triangle. Alright, let's go down here and do that. I'm going to create a right triangle with the bottom and the side. So this original segment becomes the hypotenuse of this right triangle. So you create your own right triangle. Label each leg with its length. So the bottom is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Because both sides, both legs are 8. Determine the ratio. It says 1-to-3. 1 part to one side and 3 parts on the other side really puts you 1/4 of the way down that road. So if you had a segment here and it was broken up into fourths, right? 1, 2, 3, 4, and that would be the point that would be 1-to-3 because there's one section to the left of the dot and 3 sections to the right of the dot. But that point you could also say is 1/4 down the road. So we need to change this ratio into a fraction. So really it's just the first number divided by the total. So 1 over 4. So I'm looking for the first point out of 4. Right? So 1 to 3 becomes 1/4. Then what we do is we take our x distance, which is down here, and that is 8. And we multiply it by that fraction, which was 1/4. So 8 times 1/4. And then we do the y. And it just so happens on this problem, the y direction was also 8 times 1/4. So usually they're different, but this time it wasn't different. So you have 8 times 1/4, which is 8 over 4, 2. Obviously the same for both. So 2, 2, I'm going to write it like this. And that is sort of the answer, but not always. Because if you look at the first point, from the first point, which is 0, 0 this time, notice that the first point is the origin. It's not always true though. It's not always the origin. This time it is. So you always have to add back the first point. Now I know this time it's silly because it's 0, 0, but you'll see how important that is later. So 2 plus 0 is 2. 2 plus 0 is 2. I know, silly, but it's not always 0, 0. So the final answer to this problem is 2, 2. Now let's see if that makes any sense. If I go to the point 2, 2, right there, that is on the segment. And if it's on the segment, you know you're right, because there's no way you could have gotten to be on that segment unless you had done all the work correctly. And remember, it's 1/4 down the road. So what this is saying is that if I had another point here, here, this particular one right here is a ratio of 1 to 1, 2, 3. Otherwise 1/4 down the line. So that is your final answer. Let's try this one more time. Alright, example 2, next page. No steps, but we can always look back. Let's get our axes in here because they weren't drawn originally. And let's plot our points. A is 1, 4. It's right here. B is 4, 10. Which is right here. There's point A, there's point B. And we should connect them. There we go. So we're trying to find the point that it breaks this segment right here into a ratio of 3 parts on one side and 5 parts on the other. And we'll come back to that in a second. We're going to turn this into a triangle. We drop down a vertical and a horizontal and we turn it into a right triangle. We have 3 on the bottom, right? 1, 2, 3. And we have 1, 2, 3, 4, 5, 6 on the side. 3 on the bottom, 6 on the side. Now instead of using 3, 5, remember we take the first number and the total. So it's always 3 over, then you add them up. 3 plus 5 is 8, so 3/8. So remember, we go x, y. We're going to multiply 3/8 times the x coordinate and 3/8 times the y coordinate. The x and the y. And we have, let's see, 9 over 8. Right, which is what, 1 1/8. And then here we have 18 over 8, which reduces to 9 over 4, which could reduce to 2 1/4. Right, 4 goes into 9 twice. So this is ugly. We have 1 1/8, comma 2 1/4. And we aren't done yet because this time the first point wasn't the origin. So we add back the first point, which was 1, 4. So we add those together, and our final answer is going to be 2 1/8, 6 1/4. As ugly as that is, let's see if it makes sense. 2 1/8, 6 1/4. So if I had a point and I wanted to plot it at 2 1/8, so 2 and a little bit more, and then 6 and a little bit more. 1, 2, 3, 4, 5, 6 and a little bit more. There it is, right on the line. And that is the point that has 3 parts to the left and 5 parts to the right. 3 to 5 ratio. That's our final answer. Let's do one more together. We'll practice more tomorrow. Alright, got to get the axes on here. Mine aren't on there yet. And we're going to plot the points 2, 5 and 8, 11. Uh-oh. I'm going to have to go 1 over the graph. And that can sometimes happen. I could have avoided that, but I want to show you what happens if I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, I'm 1 off the graph a little bit. That's not a tragedy, because we can, when we connect these, can we draw our triangle? We're going to know when we count exactly how long that was. So the bottom is 1, 2, 3, 4, 5, 6. And the side is 1, 2, 3, 4, 5, and then don't forget that one, 6. It happened to be 6 and 6. Now notice something, because tomorrow's video we might show it this way. 6 and 6. Could you do this without a picture? How far do you have to go from 2 to get to 8? You got to go up 6. How far do you have to go to 5, or from 5 to get to 11? You got to change by going up 6. So you could actually do this without a picture. I just like the visual part of it. But if you can see the gap between here and here, and then the gap between here and here, that's really the same thing as your triangle sides. Okay, so now I have this 1 to 2, but we don't go 1 to 2. We go first number over total. 1 plus 2 is 3. So I have x, and I have y. And I'm going to take 1/3 and multiply it by the x coordinate. 1/3 times the x. And then I'm going to go 1/3 times the y. Happens to be the same number. This time it comes out nice. 6 over 3 is 2. 6 over 3 is 2. And then we have to add back our first point, which is 2, 5. Which means our final answer is 2 plus 2 is 4. 2 plus 5 is 7. Double. You can check your own work, because if you go to 4, 7 now, let's see, over 4, up 7. 1, 2, 3, 4, 5, 6. Look at that. Boom. Right on the line. We are right on that original purple line. So you know you're right. 4, 7 is your final answer. Just got erased here, so I'll write it again. 4, 7. Alright. Upload a picture of page 6, and we'll continue with this tomorrow.